Can be fun with me, Stephen Thomas. In September, there was a paper 1 question 4 which read as follows. A helicopter at an accident scene is moving vertically upwards from the road at a constant velocity. When it is 27 meters above the road, a camera on board falls off and free falls until it reaches the road 4.35 seconds later. Assume air friction is negligible. Explain why the camera is an example of a projectile, because it's only got one force of gravity, weight acting upon it. Calculate the magnitude of the velocity of the helicopter as it is moving upwards. Now, I have opened another page here called nutsfornews.info/P1 or paper 1, and we're going to show you how we can use this web page to solve these kinds of problems. So this is a problem on motion, so we click on motion in this web page and it brings up the various formulae which we can choose from to solve this problem. Now the only trick here is that helicopter's moving upwards, camera's moving with it, initial velocity is the same for the helicopter and the camera. So let's calculate the magnitude of the velocity of the helicopter and camera as it is moving upwards. Now this initial velocity would be V initial. If we look at the whole problem, there's no final velocity given anywhere. So this formula has a final velocity, this has a final velocity, this has a final velocity. The trick is to choose a formula which looks like most likely that we can use. Now delta y is given, there it is, 27 meters or minus 27 meters if up is positive. Initial we're trying to find, time is given, 4.35 seconds, and A or G, which is gravity, is 9,8 down. So let's just click on this formula and choose it. So when we choose it, we don't know the starting velocity, we don't know the final velocity, but we do know the displacement. The displacement is here 27 meters and it's down. Here we've chosen, because the problem starts with the camera moving up, so we choose up as positive, therefore acceleration is down at minus 9,8 meters per second to the minus 2. So we already have acceleration filled in for us. Let's put in the displacement, minus 27, and it would be in meters. Let's put in the time. The time is 4.35 seconds. 4.35 seconds later, and now we have enough. We've got the time, we've got the delta y, and we have the A there. So now we click submit, and there's our answer, 15,108 meters per second. So that is the answer to the initial velocity. It says V initial is 15,108 meters per second. Now we keep that in mind, 15,108. Let's copy that. Command C, copy that. And then we can go on to the next problem, which is calculate the distance between the helicopter and the camera 2.1 seconds after the camera fell from the helicopter. So if we were to return to the main science page, motion, let's use this formula again, and let's fill in, let's work out how far the helicopter goes in 2.1 seconds after the camera fell from the helicopter. So now we know that the starting velocity of the helicopter and camera is this, 15,108. We know too that the final velocity of this helicopter, because it's moving at a constant rate, will be the same. So we can even fill that in. We're wanting to find delta y or displacement. Acceleration, because the velocity is constant, the acceleration is now 0, and the time they're giving us is 2,1 seconds, 2.1 seconds, And now we've got all the data. Let's hit submit. And there it says that delta y is 31,727 meters. It's positive. That means the helicopter has moved in those 2 seconds 31,727 meters upwards. Now, at the same time as the helicopter is moving up at this constant velocity, the camera has moved up and then it's fallen possibly down. It started to turn around and fall down. Shall we, after 2.1 seconds, try and find out where the camera is from its starting position? So we could just go back, or we could return to the main science page. We've got the starting velocity. We've got the final velocity we don't know for the camera. We know that it starts there. We don't know the displacement. The acceleration is minus 9.8 again, and the time is still 2.1 seconds. So for the camera, it started the same velocity as the helicopter, but now it's under the influence of gravity, minus 9.8, and for the same 2.1 seconds, let's submit it. And look, there's the value for delta y. Now we know that our camera has gone, this is positive, 10,118 meters up. So the helicopter went 31 point something meters up, and our camera went 10.118 meters. And then all we had to do was subtract the 2 displacements, the helicopter and the camera, and then we would get our final answer. So we could have stored the first displacement of the helicopter, but there is the displacement of the camera. So we subtract the displacement, which is plus 10, of the camera from the displacement of the helicopter, which is plus 31 something, and the difference between the two is our answer to here. Calculate the distance between the helicopter and the camera. And the answer comes out as 21,61 meters. And that is, so we could now just save these distances and then just a simple matter of subtracting the two. Then draw a position time graph. Now graphs, we can't use these equations. But basically, we know that the camera will go up a little bit, then it will come and fall down and eventually hit the earth. So our position time graph will look like this parabola going up and then coming down. So it will look virtually the same as the actual motion of the camera. And so we would put time on the x-axis, and we would put position or displacement on the y-axis. And there we are done. Now I'm going to get our Kung Fu physics master to explain this as well.